So yeah, in case you do not know me, I work for ZPL as a principal malware researcher, also playing with Dragon Sector CTF team, and my main interest is reverse engineering, exploitation, stuff like that. And I have this Twitter, was probably mentioned in a couple of times in these talks. So the first disclaimer is when I received the feedback after the proposal, one of the guys that was judging the talk said I did a lot of code comparison because the code was leaked at some point, and so I want to present it. And it's not true. Most of this came as an effort of reverse engineering, and yeah, so just want to make it clear. So, long story short about ISFB, it's with us for a while right now. It has a roots with Gauzy malware. That's why couple of companies are using still names of like Gauzy for it. So there's other names that are used. You can see that's a bunch of it: Ursnif, Gauzy, Gauzy2, Rovnix, Wolftrack. Well, not really. There was some history with Rovnix. It was at some point used as Rovnik was used as a protector for it back in a couple of years ago. But for us, the story started in 2014 with a quite massive spam campaign going on in Poland, mostly hired as for telecoms, and yeah, so. And right now, it's one of the most popular bunkers, I think, in the market that are quite available, not tied to the one gang, and yeah, I have a couple of offsprings. I will mention them at the end of the talk. So yes, the name is ISFB, yeah, right? Because authors are using this name, it's on all of the code, and it was in debug modes, stuff like that. So no Ursnif, no Gauzy, no Gauzy2, no Rovnix, definitely no Wolftrack. Especially if one guy in Poland is watching, it's not fucking Wolftrack. So I'm ranting about it because I kind of big on the names, and mostly because at some point customers are going to us and asking us, oh, do you see this type of inventions in Poland? Do you have configs in web injects, what's not? And I had to drop everything and start reversing this binary or what's not, because they said, oh, it's a different thing because they get from someone else's. No, it's not. It's this one, and please use it. The same goes with a Gauzy, right? It's a name, not Gauzy. Okay, so some scale, like try to convince you that it's actually a big one. This graph probably doesn't make any sense. I'm not sure about these numbers. It's from sinkhole connections with N6 that we're running the project. And I tried to tailor it to the way that the ISFB is on the top. But yeah. As I said, it's a crime kit. It's available for market. There are a bunch of different campaigns going on. Like this is from, I think, a couple of last months. Different, the way that you can group it by different hashes that are used. So with, it doesn't work. Well, fuck it. Oh, well. So these are most interesting groups that are around, like, and they're kind of connected. Like these three are to get run by one gang. That's all seconds. They introduce a lot of new changes and quite funny stuff. I think they were used at some point at the rough diamonds mostly. They were stealing some passports, stuff like that, and they were used in an APT attack in Ukraine at some point. Okay. A little bit more about scale. As I said, it's quite a lot of those. This is ISFB, so more than 30% or something like that. It's kind of biased because I mostly track this one, so I have a lot of those configs, but yeah. And some scale about the targets, and kudos to Slavo from SwitchStart for it. And like you see, it's mostly so a lot of comms, some Poland targets, Australia, stuff like that. Normal things that are used that you can steal money from. So let's go to the dropper. So every malware you need to start with something. and achieve persistency, inject some other part of the malware to make it working, set up IPC to connect. It's not nothing actually funny with it, and very interesting. There was a good presentation about IPC mechanism in VB this year about how the pipes are working. I really recommend it. And there is a new development with a second stage dropper, because one dropper is not enough, which is downloaded at some point. I will talk about it later. So how to detect it? There are some strings that are totally useless. There was used to fingerprint machines in old code, but right now they are totally useless. But they are always inside of it, because they are used right now, I think, in part of a random packer that's the default packer that's shipped with the code, because every malware needs a packer, and why not have a packer with source code shipped? Then you can apply another packer, another, and get a nice Maciej out of it. Well, that's a way. But yeah, they are useless for running, but they are good for error rules, because they are everywhere. So let's do this, and you'll detect all of the droppers that are unpacked. And there are some other things, but so they have quite a bit anti-VM techniques inside of it. This one is quite interesting, because what I show later, the strings inside of this binary encrypted. And as you can see, this is a function decode BSS is using to decrypt the strings. And I don't know how all of you are good with reading C, but this is kind of interesting, right? So there is a parameter passing this function. It's used as a seed. I will show it later. And it's only, it's passed based on the movements of the mouse. So if you have a shitty sandbox that doesn't emulate any movements, you will never get the proper decryption out of it. Or if you do just looking at it without any mouse movements. So that's a problem. There are other anti-VMs, like just normal checking of a virtualization method, like get a string and check it. Totally useless things, but well, why not? And to the string encryption. So like every malware, more important malware, there is cannot be known in strings, because they can be used as error rules or other rules or whatnot. So the strings are encrypted. Oh, sorry, it's not really encryption, but why not? But what's actually fun, what's interesting about it, they have a string that is used for decryption, and it's a compilation date. So a lot of research is always showing that some samples are coming from this day, that day, based on the PE header, which is totally spoofable. You can pass there anything you want, so it's not a very reliable method. But for this, it's actually compilation date, so it's kind of reliable, because it won't decrypt properly. There are some checkings to make it sure that's actually encrypted correctly. If not, you encrypted it back, because you got a bad key, probably because of the mouse movement wasn't good enough. So so there are two types of these movements. That's I saw in wild. It's 0 for older version. So that was a shitty protection, and there was like 13 or something like that. So you can always just brute force these two types, and you get a string encryptions by hand. So one of the nicest thing about this malware, from my point of view, is how they are storing stuff. So one of the most important part of PE files are resources, right? There are other fields that you can store, icons, graphics, whatever you want to do it, and it's mostly used for a malware to store another payload or configuration. Like for a trick bot, they have everything in resources, so make it quite easy. And with ISFB, I think that's actually starting from GOSI, so it's like going back to 2006 or stuff like that. They have additional resources, let's say. It's called joint resources by the authors, or FJ structs. I think it's the name that's running inside of the industry or community. So you can look at this as an additional part of resources, right? It's a bunch of structures that are coming after the PE header. There's some magic, it's FG always, and address, size, CRC42 name, and some flags, which flags are mostly the size, they can almost only used as if they are actually packed with compressed with IP-lib or not, nothing else with those flags. That's interesting. And the CR names is kind of popular because you don't want to use strings. Then CRC hashes are nice because they're fast and like that. There are a couple of CRC hashes that are useful. Most important are CRC client, CRC client 64, public key, client in use. So that's a client 32 and 64 are additional binaries. Because you have to make a decision if you are on the on which type of system you are on and drop the proper worker. Client in is static configuration data. I will talk about it later. And the public key that's used for encryption, and there is a new one. I saw it from last couple of weeks. Didn't have the time yet to analyze it. Doesn't look very interesting. Some sort of TLD is there and some stuff like that. I don't know what it's actually used for. Okay, so there's always changing things because you cannot write one malware and have gone with it. So at some point they decided let's make our life harder and do some changes in it. So because it's a 10 years old code, so you need to change it at some point. And there is a J1 structures, which are basically the same, but with shifted fields and different magic, but nothing else. So a little bit more about static configuration. It's kind of similarly structured, like you have flags, values, names, stuff like that, and count of it, how many. And the offset is actually quite interesting because it's stored in a specific way. I think I forgot the picture of it. Well, so it's structured like that. You have you can see it. We should be able to imagine how it works from here. So you have a count of it, a bunch of those structures, and there is a string table after it. So the offset is used to get a value from the string table. That's a similar thing like in ELF of Linux binaries, when you have offsets to the string table, not the actual pointers. And there are tags, so there are fields. There are a bunch of it. I think I identify like 20 or 30 of those. I think all of them are available in the paper that will be released at some point, I think. But those are more important ones. So it's address of the CNC, the bootstrap address. I will talk about it later a little bit. Then botnet ID, some keys, bunch of domains to CNCs. You see, it's a bunch, two types. So there's the GAC, the GA base URL. I will talk about later, TLD, and some Tor stuffs. Well, and it basically looks like this. I think it's only one that actually fitted. So you have a bunch of things like that. And there's a RSI key, the key for a botnet, timestamp, cookie, or stuff like that, or that. A lot of those. Okay, so since this is a bunker Trojan, let's do a man in the browser. Dynamic configuration, it needs injects. And so one of the things that I like in new botnets, new malware, is that they're starting to using structurized data structure, structurized way to store things like using XML or JSON or whatnot. But it wasn't the case with old school malware like Zeus or Gozi or ISFB or whatever. There's a bunch of or Volchak for that matter. It's a mess of binary data stuffed together. Well, the binary structure from Zeus was kind of elegant. I talked about it a couple of years ago. But this one is totally messed up. Like you have 6 fields that have size and data, and they are totally randomly selected based on how many data is inside of these fields to will actually be used. But for more important part, there's a target and an action that will be executed on it, and it's actually not really that thing, because if the target, so if the action is not one of the strings that are used as an action, it's a URL pattern, so regex to match on the site to see if you can change it. Well, stuff like that. So yeah, basically web injects, nothing funny about it, just a web injects. But web actions are actually quite nice. And so basically file stealing, screenshotting, hiding things from you, new grab, whatever, video. And I didn't saw video much till someone showed me this yesterday. So you can just why do screenshot when you can just record the video of it and send it back to you, so you have everything the actual guy is using to look to the bank for, or Twitter or what's not. Okay, send the post data and run the VNC and processes a web fake. Yeah, a couple of web actions. So with web fakes, so with web fakes is actually quite an interesting story, because when Dire was starting using it, was a lot of fuss in community. Oh well, you can redirect the page and have everything. Well, Gauzy has it the Gauzy has it, so it's like 10 years old concept, which is quite helpful, because for one thing it can hide. I don't know if it should be in this web inject. It's not. Oh well. So as you can see, you can redirect part of URLs to somewhere else, and if you look at the injected code inside of the browser, you wouldn't see any suspicious addresses like, this is my ATS, please don't use it. But you see only the slashes and stuff like that. So the requests, when you log in requests from point of view the browser, you will only see the bank domains, which is nice. So it's not that suspicious. And the other thing is this completely bypass the CSP, right? Because there is a proper domain going on for a browser. From browser point of view, the changes is done on the network level, not on the browser. So browser doesn't see anything. So CSP is basically useless. And it's also, CSP is also bypassed in other way, like the easiest way is just to strip the headers. Why not? So yeah. And VNC is, it's quite okay, because you can log in and during someone's being making some operation, you can log in and do it for him. You have to remember passwords, something like that. Okay, so a little bit about the bot itself, IOCs or what's not. So it stores a lot of information inside of the registry. It's a pattern for it. It's kind of similar to Zeus, if I remember correctly. And there are a bunch of names that are used: install client, netcfg, we'll talk about it later, last task, config. And right, the install have information about installation, basically. It's like bot ID, bot UID, and I think nothing else. Client is a binary. netcfg is a bootstrapping list that's a list of peers. Last task and last config are CRC hashes of last task and last config. And some other actions you can perform, because stealing money from banks, from clients of banks, is not that funny at all. You need some other things, like steal some certifications, cookies, information about system, load additional malware to perform some nastier actions. Start socks and get some keylogging, mails, FTPs, VNC, what's what. So nicest use of get files was the one of nicest use of the get files was stealing passports, because at some point you need to run. Yeah, a little bit about CNCs and how to communicate with the network. So it has every possible method right now that you can communicate with CNCs, right? So there are static domains inside of the configuration, and there is a DGA based on a template and current date. This template is quite nice because there was a template URL which basically goes to the page, downloads the page, and do some actions on it. We'll talk about later. And there is a CNC hidden in Tor network because Tor is fun. Since there is no avalanche, you need to move somewhere else. And the peer-to-peer network, which I never saw being used, but the code is there. It's a messy, and apparently it's based on the Emule torrent sharer. Okay, so about few words about DGA. The code is simple, nothing fancy there. But what's fun is that's actually fetching the templates from internet. Like you see, for the first version was a US Constitution. At some point there is a RFC from GNU, stuff like that, but different things. I think you can see some earlier, should be. Oh yeah, so Apple. Yeah. So it fetches this template, split it by words, and then do some mixing. So you have you cannot find the DGA based on the only analysis of how many letters or how much letters are there and how frequently they are appearing. Oh, nice one. So there are a couple of funny stories about it. It has a couple of bugs. And so the DGA is a little bit of new concept. It was added 2013, 14, something like that. But the code was actually presented in first GOSI version. So and wasn't used as a DGA. It was used as a suggester for domains to register. And the funny thing, there is a bug inside of this buffer overflow that was described by Swiss GovCert, I think, up a year ago or 2 years ago. And the same bug is there for 10 years. There is other bug, but it's not happening very soon, very oftenly. I think never happened. But yeah. Tor is simple, nothing fancy. Just download the Tor client and browse, run the traffic through Tor. So there's nothing to talk about it. And peer-to-peer, it's a new addition in June or something this year. I had no idea about it. I saw the bootstrap field in static configuration and was some IP addresses, but it was never used. Had no idea what it was until I started writing slides and paper for BotConf. And we sat down and tried to analyze it quickly, like spent 5 hours on it, 4 hours. It's totally messed up code. Like ISFB is nice. It's nicely structured code. It's easy to read with no problems. Quite nice experience. This part, oh wow, totally fucked up things. Like totally different code, totally different ideas how to write. I think it's called bydlo code in Russian. Like the code you shouldn't be writing or reading anymore. You just should kill yourself. So it's kind of interesting because there is a handshake in it. So it's there was some thinking going on with it. I don't know if this part is still in Emule, or I didn't never read the code. I just heard about it yesterday. That's something I need to verify. But there is a handshaking going on, like secret handshaking. You send part of your secret, and initialize it with it, generate a couple of others, and send back, stuff like that. Well, there is RC4 going on with it, also because it's the simplest encryption. But internet is hard, right? I don't know if you can see it. What's domain? So at some point they started to, I don't know why use it, but they maybe to annoy researchers or what's not, start to adding the fake domains, the legit domains that actually are okay. Like this here is a spam house, and you will be expecting if they added, they wouldn't be calling it, but right now it's logged from my sandbox. It's a bunch of calls to spam house. Well, I don't know, maybe somehow it's compromised. But that's actually a nice way to, the sinkholing. You don't do you need to do anything right now. Just, have a request, decode it, and be done with it. A little bit about URL, because you can see it's quite interesting. I don't know if anyone can see it. No. Oh well, the slides are online. You can see it later. So the URL format was evolving over time. It started simply. That's part from Magosi. That's what I saw first time, and it decodes to something like that. Right now, it's something like this. So how it goes? So firstly, it was this letter was mostly important. It was a definition of what type of request it is. We can see it's a T. There was a D, C, and I think that's all. There's some random bytes, and some data, like this data. So this is just base 64 with encryption. There are two types of encryption supported. The older one version is RC6, and right now there is a Serpent. Few words of the Serpent will be later. But it wasn't, I don't know, enough for them to have things like that. They go to something like this. Maybe to hide traffic, I don't know. Maybe for someone it looks legitimate, I don't know. Never saw images with. So they used extensions to distinguish between, like, this first letter. The extensions are used to distinguish what type of request it is. Apparently, to hide it from plain sight or stuff like that. So basically, it's almost similar. You need to. Oh, well, there should be some code, right? For the decryption of this, you need just to strip the extension, decode base 64, decode it, and remove some slashes from it, stuff like that, and get the request. That looks like this with those versions. Like that's a CRC of last configuration, some ID, the group ID, random things, server never used, software can be changed, bot ID, and version. So yeah, that's how the URL format looks like after decoding and on the CNC. So like it was a TCD for getting task config data, but it's too not that fun. The images are more funnier, or whatever. I'm tempting to say GIF, but well, I take GIF. JPEG and BMP are used as extensions to distinguish between task config and data. And for the second stage dropper, there is an AVI with a bug, obviously, because like you can see, there is a slight change. You have to always finish it with a slash. So CNC is responding with Serpent RSA because you need to be secure and everything should be signed. Actually, I stole this slide from one presentation about name. So there will be a bug on the next one. So at the end, there is a RSA encrypted header with some padding, hash of the data, Serpent key, and we need to decode the Serpent to get what's inside of it. It's used for every type of response from CNC. Because you upload the encrypted file to it, and so it's for a configuration for web injects, for binaries that will be downloaded later, and for a Tor client, which is kind of important. So yeah, Serpent. It's not that well known in cryptography. First time I saw it, I had no idea what it was. I had some hits on RC6, but it wasn't RC6. So I just dumped the code and ran the binary from it. But it seems to be a second submission for ASA and almost won it. It's quite nice. So there is a little bit pro tip. If you try to write it, don't use the version that's available for Python. It's on the DGO Python Crypto++. It's slow as hell because it's pure Python. So you cannot get any decent site injects in less than 10 minutes. So just use C. Decrypted data look like this. For injects, they are compressed. There is not ERCH, it's only AP42. As I said, it's from name and stuff like that. And command and control, the funny part. We managed to get some information from CNC. There are two panels that are mainly used. There is an EAP, it's from old times. And basically you can find out about it because how it's inside of the panel is used to decode the CNC form, the URL format. So right now they are using Nginx and those type of rewrites. Well, apparently there is no bug here, but in code there was one. It looks like this. Nice one. And there's no. So the funny thing about those type of panels, so you would suspect that for easiest using, you just can upload the sample or CNC configuration data, and that will be encrypted on the panel. But it's not the case. You have to upload the already encrypted and signed code files there. The second one is the Dreambot. I think it's appeared on 2014, stuff like that. Yeah. The name wasn't used by anyone till February this year or something like that. So they go to the different route of handling things. They add another layer of functions. More functions, more bugs. Why not? I'm sorry. So there are rewrites from htaccess, and so they are redirecting to file. The part of the files will be in paper. That's a funny story, but it's not TLP Red Talk, so no. The panel looks like this. The funny thing is, it's written in Perl. I will suspect some reaction, but no, okay. So who normally code in panels in Perl, like web servers, web applications? It used to be in PHP, but I think they cannot find out how to patch the bugs I was using, so they switched to Perl. Well, until recently, I had no idea how to distinguish those two bots based on binary on binary level, but it turns out the part of the VM fingerprinting is only done in Dreambot, so it's easy to know, to just find it. So just use this URL, and this will be everything. Oh no, a couple of offsprings. So the code for this was leaked a couple of times, so obviously there will be some new developments. I think most important part development was incorporating ISFB code into name and making the ghost name. I won't comment. But there was something that was called power sniff, punchy bug, mini URL sniff, stuff like that. It was used to steal from a little bit targeted attacks. It was quite nice. Most of the ESFB part was stripped off, but there was much more smaller. I think Caffeine was blogging about it, and some guys from Palo Alto, I think, I don't remember. And there are a couple of common routes and payloads. Like the Bolek or keyboard, as I call it, is based on the same code base. It's based on Gozi. Rovnix was used as a protector for ESFB for a long time before. And Wolftrack have nothing to do with this part in terms of code. Actually, the guys that are running the Wolftrack, they wrote Wolftrack, the NeverQuest gang, have a roots with Gozi. There is an excellent post by, I forgot the name, Dan Jackson, I think, from Fish Labs. I really recommend it. It's a good story how the Kuznin guy was arrested and how his history goes. And yeah, to quite quickly recap it, it's one of the oldest bunkers that's still there. some interesting solutions inside of it. You know, elaborate communication to connect with DGA, with CNCs, and all the bugs are hard to patch. Well, there is some more details in paper, and I will be releasing some code to know decode it and have fun with it. And some kudos, because this research was supported by many people, mostly by Slavo and Paul Black for the review, and Caffeine for samples and insights, and other guys for different things. And yeah, I'm done. Thank you.
Okay. Questions? There you go.
Thank you. That was interesting. I'm curious about this spam house request. Is there a spamming component in the malware?
No, it's only stealing a couple of mails. Most of the distribution is based on AKs right now. Split kits are dropping a lot of those. There is some spam going on with it, but not very oftenly.
From the infected machines?
No, it's a different part.
That could be a reason why it wanted to know if it was on the blacklist. And
well, no, it's actually it's using normal requests, so it's totally normal traffic for a bot. You know,
yeah.
It's like just a different, curious mistake.
Yeah.
The other fake is a Pornhub, Pornlab, and a couple of others.
Maybe they're using VNCs to watch these sites through someone else's.
Maybe.
Yeah.
Questions?
Who's been working on this? No one. Ah, yeah. You don't have a question?
They know everything.
Okay. Okay.
It's a quick one. So
wow.
the peer-to-peer structures that you show is our implementation from the assembly, or is actually source code?
No, it's a totally real. It's from assembly.
Okay.
Okay. 1, 2, 3. Okay, thank you.
Thanks.